Afternoon, Professor. This is Uzman Jallo, and this is my video of me going through my final project for the semester. So, um, so the first cell that we have is just me importing like the necessary stuff in order to do the data analysis. So we're importing the pandas library, the NumPy, the Matplotlib, and Seaborn, all that good stuff right there. Uh, so in my last previous projects, you might remember I worked with the COVID-19 data set. Well, for this project, I decided to, you know, work with something related to sports, particularly basketball, since basketball is one of my favorite sports. And since, the Knicks are doing well so far, it kind of fits into the whole thing, going on right now. So I found the data set on GitHub that was about, it had all the stats for players that played in the 2015 to 2016 NBA regular season. So I decided to use that data set, you know. So this is me, getting importing the data set, getting it mounted, and then checking to see if everything went smooth. So the next portion of the notebook is just me, wrangling the data. So we first check to see how many no values do we have, and how many of each column, because we have a lot of columns. There's like 35 columns that we are working with this data set. So it's significantly bigger than the last one, So after seeing this information, we decided to drop the rows that had no values, and it still left us with a significant chunk of the data to work with, and we can do some meaningful analysis. So after dropping those rows, we we can see that there's no more no values there. And then this is me right here checking to see, the types of columns that we have, which unique columns do we have. And then this is also me checking, to see which type of data types we have. And for the most part, we're dealing with a lot of floats and integers, which means that we could do analysis that requires like addition and subtraction. However, one thing that I noticed was that the salary wasn't a float or an int, and I really wanted to do some like math mathematics with the salary column. So I decided to convert that from a string to a int. So this is the code that did that, and then after we ran this code right here, you can see now salary is an integer. So that's good. And then we went through check to see if there's any duplicate uh, rows. There was none, and then we just double checked, to see the data right here. All right. So now with the data, wrangled, and we made sure there's no duplicated rows, and like we have everything that we need in order to do the analysis. Cause just to throw in there, I didn't really want to drop any columns because I felt like each column was very important. Like if I kept all the columns in the data set instead of minimizing it, it gave me more options of like what kind of questions to pose, and like what kind of probabilities, and how could we look at this data and everything. So for the visualization portion of this notebook, we the first thing that we was gonna do is compare the average field goal percentage between all five positions. So this is the code that we wrote, and like the code is gonna group by position, and it's gonna also look at the field goal column and calculate the mean, of all of each group, right? And then when we do that, we're gonna plot it, and this is the plot. We decided to go with a bar graph. Now, the thing with this data set is unique because in traditional basketball, there's only five positions. You got point guard, shooting guard, small forward, power forward, and center. However, there is players out there that do play like a combo role. So you will see like sometimes you'll see a shooting guard that will sometimes play small forward, and this data set actually does take into account of those players, which is why you'll see more than like five bars. You'll have like seven right here, right? So it has the shooting guard, the small forward combos, the power forward, the center combos, and then like based off of this graph right here, we came to a conclusion that bigger players, or players that play a position that's traditionally tall, would like have a higher likelihood of having a higher field goal percentage, which makes the most sense because they will be taking most of their shots closer to the basket, which is a higher percentage shot anyway, right? Uh, and then like this is me, displaying like the average field goal percentage. So we'll see like centers had like a 50% field goal percentage, power forwards 46, small forwards are 43, point guards at 41, and like the combo shooting guard small forward shot an abysmal 38%. All right, and then the next visualization we did was to check the distribution of the age in the NBA during the season. So when we did that, right, we created a histogram, and it will keep track of the frequency of each age group, right? And then as you can see here, it's not normally distributed, and it's kind of skewed a bit to the left, which indicates that a lot of the players playing in this season were tended to be younger. So we're seeing like majority of the players be in between the range of like 22, like above 23, but in between 30. So a lot of these guys are not even old. Okay, and that was the conclusion I came to as well here. And moving on to the next part of the notebook, which dealt with the probabilities. We decided to come up with a couple of probability questions that we could try to answer with the available data that we had. So the first one was, what is the probability that a player averages more turnovers than blocks? So what we did was, first we set the condition to where we created a new variable, and in this variable we're going to store only players that had a higher turnover a higher turnover than blocks, and all those players will get stored in here. And then all we had to do was just calculate the lengths of of the players stored in this variable right here, and the total lengths of the whole data set, and we got the probability that way. Another probability question we posed was, what is the probability that a player averages 20 or more points in the 2015 16 NBA season? It was the same thing. We set the condition, we stored in a variable, and then we calculate the length of that variable and the length of the total data set, and then we just do the division, and then we're able to get that probability right there. Same thing. What is the probability that a player averages more than 20 points and is older than 25? So with this form now, we're including an and condition as well. So we're accounting for two things. So it's the same process, we're just gonna filter the data. Once we got that filtered data, we just get the lengths of that data and then the total lengths of the whole data set, and then it's the same process as the other two above. And then like the last question we posed was, what is the probability that a center will average at least 10 rebounds and average at least 1.5 blocks? And it was the same steps as above. Moving on, and this is the part where I kind of ran into a wall, and it was probabilities based on normal distribution. Now, the issue that I was having was that my data set, because I had so many columns, right? Like if I did a normal pair plot, I wouldn't really be able to like tell just from looking at the pair plot like which columns would be normally distributed. So the solution I came up was, basically just take all 35 columns, break them up into different groups, and we're just going to make separate pair plots for each one of those groups. And then once we've done that, then we can look at the multiple pair plots that we are going to have, and then look to see which columns would most likely be normally distributed, which is what I did right here. We selected columns, and then we created a pair plot of those selected columns. So this is like the first one we did. Here is the second one. Here is the third one. And here is the fourth one. I think we only have four. Yeah, we only have four, right? And then once we, did all that and we looked at the data, the next thing that we wanted to do was to basically jot down which potential columns could be normally distributed. And we came with three, which was the 2-point percentage, minutes played, and personal fouls. So now that we have these three, right, it's not good enough to just say, okay, well, based off of visual observation that these columns are normally distributed. We decided to make a QQ plot and to actually, test it and see, right, which is what we did right here. We made a QQ plot for each one of those columns, and Um, and based off of those QQ plots, the one that was the closest to having a normal distribution was personal fouls, right? And as you can see, like the ones above, like minutes played, that's not that's not normally distributed. And then like QQ, this one for 2 point percentage. At first, I wanted to give it like maybe, but then like I decided nah because of like this area down here, like it was just too close to call. So, but however though, with personal fouls, it was much more closer to the line, and I like that, right? But just to confirm it for the last time, we performed the Shapiro Wilk test to confirm it, and when we did, it came back as good, and and we concluded that personal foul is normally distributed. So now that we have our normally distributed column, we then propose those probability questions that you can see right here. What is the probability that a player averages more than two personal fouls? What is the probability that of the 38% that commit more than two fouls that they are centers? And then what is the probability that a player averages three or more fouls a game? And that's how I was able to overcome this portion of the book right here. Moving on to confidence intervals. Right, first thing we did was we had to import the T distribution library and the norm. And we're using the T distribution because we don't really know the popular standard deviation or the popular mean. So using the T distribution, first we was going to calculate confidence interval for mean points, which is just like the average points per game. So this is what we did right here. And like once we done that, we concluded that we are 95% confident that the true average points scored by NBA players in this season is between 8.6 points a game and 9.8 points per game per player. Then we did the same thing for salary. So we wanted to calculate the average salary, the confidence interval, and doing so, we concluded that we are 95% confident that the true average NBA player salary was between $46 million and $97 million per player, right? So it's in between that range. We're 95% confident that it's in between that range right there. And then for our last question, we just do a question out there like let's calculate the 95% confidence interval for the proportion of players scoring more than 10 points per game. And in order to do that, first thing we did, we got the amount of players that scored more than 10 points per game, and we stored it in NumPlay right here, and then we did our calculations, and this is the result that we got right here. And then we concluded that we are 95% confident that between 31.4% and 41.6% of NBA players scored more than 10 points per game in this season. Moving on to the next part of the notebook, which was the hypothesis testing. We wrote, in the year 2025, it is claimed that the average NBA player averages 10 points per game. We believe that this assessment isn't true and believe that the true average is much higher than that. So we used the significance level of 0.05, and then we defined our null hypothesis as the mean equaling 10, and our alternative being that the mean is greater than 10. And when we ran this code right here, and we are using the T test for this, we failed to reject the null hypothesis, and we concluded that there was not sufficient evidence to suggest that the mean of points in the sample is significantly greater than 10. Moving on to our next question right here, we want to test our hypothesis that the average player in the 2015 NBA season was greater than average salary in the season was greater than 5.5 million. We used the significance level of 0.05, and we used it for like all of our hypothesis testing, and then like we defined a null and alternative hypothesis, and we ran the same thing, and in this one we also failed to reject the null hypothesis, citing lack of sufficient evidence to disprove it. And then, like, this is the last question that we did. We want to test our hypothesis that the top 50 NBA players had an average effective field goal percentage greater than 50. Now, with this one, the way we calculated, the way we got the top 50 NBA players was that in the data set, they had a column RK, which stood for rank. Like, they ranked the top 50 NBA players. And then, so all we did was just, we took the top, we created a conditional statement, you know, where we only wanted those players that had a rank less than or equal to 50. And then, we stored it in this variable right here. And then this is me, just going through, seeing the top 50 NBA players of that year. And then once we had that, you know, we ran this code right here. And then we failed to reject the null hypothesis. And then for the last section of this notebook, the chi-square tests, for ours, we decided to let's determine whether the position of a player is associated with their three-point percentage. And I thought this would be a fun question because I remember watching basketball around this time. There was a lot of debate about the three-point shot because of the Warriors and like how effective it was and how it couldn't win. You couldn't win, with just shooting threes. So it was. I thought this was a nice question to ask. And our null hypothesis is that the position of a player and their three-point percentage are independent. The alternative is that there is an association between the position and the three-point percentage. So this is me importing the Chi to contingency, and then we made our contingency table, and then we ran this code, and these are the contingency tables that we had, and then after running it, we concluded that. We concluded that we failed. We reject the null hypothesis, and the results of the code running suggested that there is a correlation with the position of a player, and their three-point percentage, and this could be due to the fact of spacing and the roles of each player on a team. And then here we're doing another one where we determine whether field goal percentage is associated with field goal attempt. The null hypothesis is that field goal percentage and field goal attempts are independent. Alternative is that there is an association between these two. We did the exact same thing that we did up here, and after doing so, we have failed to reject the null hypothesis, and there was no sufficient association between the field goal percentage and the field goal attempt. I hope you enjoyed this video, Professor, and I hope you have a good summer.